everyone, this is your first of two videos on section 1.1, Analyzing Categorical Data. Go ahead and title your notes with that title, 1.1, and include the three learning targets. The three in black are the three I'll talk about in this video. The three gray ones are for the following 1.1 video. So today we're going to talk about make and interpret bar graphs for categorical data, use bar graphs to compare distributions of categorical data, and identify what makes some graphs of categorical variables misleading. Pause the video here while you title your notes and list those three learning targets. On this slide, you see a graph with the title Instagram Global Engagement. I want you to pause for a moment and ask yourself what you noticed about this graph and what you wonder. After you've paused and given yourself some time to think, maybe you noticed that the highest levels of engagement, the dark purple color, happen in the middle of the day from about 10 to noon on Wednesdays and Fridays. Maybe you wonder why this is. Maybe you've come up with a couple hypotheses, like people are ready to sort of check out of their work or school week on Fridays, and so they're on Instagram more, looking forward to their weekends. Maybe you've noticed that the lighter colors happen when traditionally most people in the United States are asleep from about the hours of 10 to 11 p.m. until about 5 or 6 a.m. Today we're going to be talking about frequency tables. These are just tables that show us the counts of the number of individuals having some value. Frequency tables are just a way of organizing our categorical data. We can also have a relative frequency table where instead of showing the total counts for the number of individuals in each category, we show them as a proportion or percent of the total. Here we see two examples, one of each. This example is data taken from 10 randomly selected Canadian students about their preferred method of communication. In the frequency table, we can see the counts that 2 students preferred cell phones, 1 preferred Facebook, 3 in-person communication, and 4 text messaging. Notice in the relative frequency table, those have been turned into both fractions, percents, as well as proportions. So we can see out of the total of 10, or as a percentage, which method students preferred. We use frequency charts and relative frequency charts to be able to make a graphical interpretation of categorical data. You've probably seen these before, but make sure you write down our definition for our statistics class. A bar chart shows each category as a bar, and the height of the bars corresponds to the frequency or relative frequency. Notice in the bar chart down below, I can easily see that text messaging was the most preferred method of communication, and the height of the bar corresponds to 40% of the students with that response. I can also see that Facebook was the lowest chosen method, with only 10% of the students choosing that. Similarly, in the pie chart, I see each category as a slice of the circle or pie. The area of the slices are proportional to the frequency or relative frequency. So again, it's very easy to see that Facebook was the least chosen method with only 10% of the pie, whereas text messaging was the most preferred method with 40% of the pie. It's important that both the bar chart and the pie chart were able to proportionately see which method is most preferred and least preferred. When we make a bar graph, there are 3 steps that are essential to being able to clearly communicate to the viewer what our data shows. The first is to draw and label both axes. So your bar graph is not complete until you've given the horizontal axis a name, which usually means naming each of the categories. And the vertical axis has some sort of scale, whether it's the frequency, just the counts, or the relative frequency where you list the percents. The second step is it's important to scale both axes. The vertical axis needs to start at 0 and must go up by even intervals. So for example, if I'm going to go up by tens, I need to do that consistently the entire time, 0, 10, 20, 30, 40, etc. I cannot change the scale in the middle of my graph. So for example, I cannot go 0, 10, then 30, then 40, then jump up to 70. Finally, when you go to draw the bars for each category, each bar should have the exact same width. I'm going to give you an opportunity now to practice that. Down below in example 2, you see the responses from 40 randomly selected U.S. high school students who completed a survey asking, which would you prefer to be? Rich, happy, famous, or healthy? Pause here to make yourself first a relative frequency chart where you're going to count the number of responses for each of those 4 words and then figure out which proportion they are out of the total. Then use that data to make a bar graph. You can either do this by hand, or on the next slide, I'm going to show you an online applet that I use to make a quick and easy bar graph. If you prefer to do it by hand, that's fine as well. But pause on the slide so that you're able to first get your counts of how many students responded to each word. Whenever you're making a frequency chart or a relative frequency chart, your final step after you get your counts should always make sure that they double check to add up to the total. In this case, make sure your counts add up to a total of 40 students. Here you can see my counts for frequency. 8 students responded that they would prefer to be rich, 21 happy, 7 famous, and 4 healthy. To make my bar graph, I used an online applet at the following website. I went to statsmedic.com/applets. I chose from all their different options of charts to make the one that said one categorical variable, single group. Since I just have one categorical variable here, the choice that students said for their word, and it was for a single group of students. I input my data first, and then I chose relative frequency bar graph. Here's what my bar graph looked like. From this bar graph, I can see on the left side the relative frequencies. Notice the scale starts at 0 and goes up by 5% each time and is labeled relative frequency. At the bottom, I've labeled the axis the life preference for high school students, and you can see my 4 categories: rich, happy, famous, and healthy. From this graphical display, I can easily see that happy was the most chosen preference for most students, and healthy was the least chosen, while it looks like rich and famous were about equal. Notice also that the width of each bar is the exact same, so that I can easily compare just the heights without being distracted by different widths. Double check that your bar graph, whether you used the StatsMedic applet or drew it by hand, looks similar to this one. When we're making bar graphs or pie charts, we want to be careful. Well, you've probably seen bar graphs throughout your mathematical career, beginning as early as elementary school. You might think that over time they can be a bit boring to look at, so sometimes people are tempted to replace the bars with fun pictures or try and make them more interesting with different scales. We will never want to do this in our AP statistics class. When we use pictures that are not proportional to one another, or use different scales that do not start at 0 or grow up by even intervals, this can make a graph very misleading. In summary, use the boring bars in the bar chart and start your vertical axis at 0 every time. Here's an example as to why. Example 3. Apple asked 500 buyers who were buying a new iMac about what their previous computer had been. The frequencies and relative frequencies of the results are shown in the table below. Then 2 provided graphs are shown, and each of them is misleading. Our question is why. So notice here that it looks like 85 out of 500 people said they previously did not own a computer. That equated to about 17% of respondents. 60 people out of 500, or about 12% of people, said they previously owned a PC. Well, 355 people had previously owned a Mac. That equated to about 71%. there's two different graphs. The one on the left here uses pictures. Notice in this picture, the picture of the iMac looks almost 10 times as big as the Windows computer or the computer that represents none. When in reality, 17% and 12% only is about a fifth as large as the 71% of Mac users, not 10 times. So the reason this graph on the left is misleading is the pictures make it look like almost 10 times as many people already owned a Mac. On the right, we can see that the vertical axis starts at 10 instead of starting at 0. This makes it look like the number of owners who previously owned a Mac is much, much greater than it actually is. Okay, so each of the bars does go up to the correct number. None hits at about 17%, PCs hits still at 12%, and Mac just over 70 at 71%. But by starting the axis of 10 at 10 instead of 0, we get rid of 10 out of 12% of PC owners. So well over half of PC owners, their bar has gone away. For those who previously owned none, by getting rid of 10%, we also get rid of over half of that bar. This video should have gone through 3 different examples that show you 3 different skills for today. How to make and create a bar graph, how to use that bar graph to interpret categorical data, and then how some bar graphs can be misleading if we're not careful to use even with bars and always start our vertical axis at 0.